Within the booming renewable energy sector, Bloom Energy provides stationary fuel cell power generation. It manufactures advanced fuel cell energy platforms like the Bloom Energy Server for generating electricity and the Bloom Electrolyzer for producing hydrogen. Its over 1.4 gigawatts of energy server systems are deployed in over 1,000 locations across 9 countries. Bloom has capitalized on key trends in the power generation business, including increasing demand for power driven by data centers and artificial intelligence. The growing importance of time to power is also a significant factor, as utility companies struggle to keep pace with demand. Bloom Energy's solutions address these challenges by providing behind-the-meter, on-site distributed power generation that can bypass lengthy interconnection queues and transmission upgrades. Bloom's fuel-flexible solutions also address reliability concerns and near and long-term sustainability considerations. Its energy server systems offer up to a so-called 5 nines, 99.999%, using a microgrid solution, making them suitable for supporting large, critical customers and key infrastructure. Additionally, the systems can displace dirtier and less efficient conventional combustion solutions, and their fuel flexibility enables them to run on biofuels or hydrogen. The market conditions for Bloom Energy's platform are promising, with customers demanding lower carbon and resilient energy solutions. Its fuel cell solutions offer compelling value propositions, including reliability, cost efficiency, and flexibility. Costs have been driven down through innovation and discipline, and its flexible platform can be utilized in various new applications. To date, the majority of Bloom Energy's product revenue has come from sales of its power-generating energy server system. Sales have increased to utility companies seeking alternative sources of power to meet growing demand. Bloom Energy's solutions are also being used in waste-to-energy applications, providing power solutions to enable lower carbon intensity renewable fuels. The U.S. is Bloom Energy's largest market in terms of revenue and installed base of energy server systems. Major customers include companies in industries such as utilities, data centers, agriculture, retail, hospitals, and manufacturing. Bloom's second largest market is South Korea, where the company has grown its footprint to nearly 600 megawatts of deployed energy server equipment. New markets and geographies are being explored with its Bloom Electrolyzer, which produces hydrogen and has opened up new partnerships and opportunities. Bloom Energy's solid oxide platform is the foundation for its energy server system and Bloom Electrolyzer, providing a variety of sustainable energy solutions. The platform has 4 core attributes: shared solid oxide technology, common product architecture, shared supply chain and manufacturing process, and flexible offerings. The Bloom Energy Server System is designed to deliver reliable, resilient, clean, and affordable energy for utilities and organizations. It operates on natural gas, biogas, hydrogen, or a blend of these fuels, and can be configured as primary power or microgrids. The energy server system can be utilized in applications like carbon capture, utilization, and storage, CCUS, combined heat and power, CHP, and waste-to-energy. The system provides a scalable, modular, and fault-tolerant design, offering operational and serviceability advantages. It is also resilient, avoiding vulnerabilities of conventional transmission and distribution lines by generating power on-site. The energy server system is reliable, with a modular design that can be configured into large-scale energy farms. It delivers 24/7 power with high availability, mission-critical reliability, and grid-independent capabilities. The system also offers flexible deployment configurations, operating independently or in combination with other energy resources. Its operational flexibility allows it to handle various customer loads, including peak loads associated with AI data centers. It's also being future-proofed for the energy transition, as it's optimized for fuels readily available like natural gas and biogas. However, it can also convert hydrogen into electricity, making it adaptable for a future with more readily available hydrogen. Bloom competes in the stationary power generation market against technologies like gas reciprocating engines, small gas turbines, combined cycle plants, intermittent solar and wind power paired with storage, traditional cogeneration systems, traditional backup equipment, and other commercially available fuel cells. Its energy server system has advantages over these competing technologies, such as higher power density, lower emissions, higher reliability, and better flexibility to adapt to load fluctuations. The energy server system can also achieve similar efficiencies as combined cycle plants with the distribution losses due to on-site deployment. Bloom Energy's solid oxide fuel cell technology also has advantages over other fuel cell technologies, such as proton exchange membrane, PEM, fuel cells, molten carbonate fuel cells, MCFC, and phosphoric acid fuel cells, PAFC. These advantages include higher efficiency, long-term stability, elimination of the need for an external fuel reformer, ability to use biogas, natural gas, or hydrogen as a fuel, low emissions, and relatively low cost. The Bloom electrolyzer, which produces hydrogen, has a higher efficiency than other electrolyzers due to its high-temperature operation. This leads to a fundamental efficiency advantage in producing hydrogen by consuming less electricity. The Bloom electrolyzer also benefits from the company's decades of experience in power generation, which directly transfers to hydrogen production. In the electrolyzer market, the Bloom electrolyzer is differentiated from other technologies such as alkaline, PEM, and anion exchange membrane, AEM electrolysis, which are low-temperature technologies using liquid water. Research and development efforts have focused on addressing complex applied materials, processing, and packaging challenges. Manufacturing facilities are located in Fremont, California, and Newark, Delaware, with the Newark facility being its first purpose-built manufacturing center. It also has a light assembly facility in Korea and leases various manufacturing facilities in California and Delaware. Bloom's supply chain is global, with suppliers in Asia, Europe, and India. It has multi-year supply agreements with some of its suppliers to ensure continuity and pricing stability. However, there have been disruptions in its supply chain due to factors such as supply shortages, shipping delays, and labor shortages. Beyond products, Bloom offers services such as maintenance agreements, remote monitoring, and repair and overhaul services. It has a dedicated service organization with field personnel distributed across multiple locations in the U.S. and internationally. To make Bloom Energy's products more accessible to a wider range of customers, it offers various financing options, including power purchase agreements, capacity agreements, lease agreements, and managed services agreements. Products are sold through a combination of direct and indirect sales channels, including a direct sales force, strategic advisors, and partnerships with utilities and other companies. Internationally, Bloom has a partnership with SK Ecoplant in Korea, which includes purchase commitments for Bloom Energy's products and collaboration on hydrogen innovation centers. Then, to develop carbon capture technology using natural gas and fuel cells, Bloom partnered with Chart Industries collaborating to provide near-zero carbon power generation options, leveraging existing fuel infrastructure. Bloom Energy's high-temperature fuel cell technology will be combined with Chart's carbon capture expertise to achieve this goal. The partnership will enable the conversion of natural gas into electricity without combustion, producing a concentrated CO2 stream that's more efficient for carbon capture. Chart Industries will process this high-purity CO2 exhaust into forms suitable for utilization or sequestration. With sequestration infrastructure developing globally, the companies see CO2 utilization as an immediate step towards longer-term decarbonization goals. K.R. Sridhar, Bloom Energy's CEO, stated that the partnership demonstrates the feasibility of cost-effective on-site baseload power from natural gas with carbon capture at scale. The partnership is already exploring projects where captured CO2 will be used in the food and beverage industry. Similarly, Bloom's ambitions have led to a partnership with Equinix, a global digital infrastructure company, to deploy next-generation fuel cells across 19 data centers in the U.S. This collaboration, which has been ongoing for over a decade, has now exceeded 100 MW of electricity capacity, with 75 MW already operational and another 30 MW under construction. The fuel cells, which were first piloted in 2015 with just 1 MW of power at a single data center in Silicon Valley, have scaled up significantly to support the growing energy needs of AI-driven computing. According to Aman Joshi, Chief Commercial Officer at Bloom Energy, The company's fuel cells are supplementing grid power at Equinix's data centers with cleaner and reliable on-site power, reducing pollution and water usage. David Renard, Vice President of Energy Operations at Equinix, noted that the partnership with Bloom Energy has allowed the company to generate cleaner and reliable electricity on-site at its data centers in a cost-effective way. This collaboration is part of Equinix's efforts to support the development of reliable, sustainable, and scalable energy infrastructure. In fact, Bloom keeps booming in data centers as it was revealed its fuel cell technology would be in use at select Oracle Cloud infrastructure data centers in the United States. This collaboration aims to support the growing demand for artificial intelligence and cloud computing services, which require substantial computing power and reliable energy sources. The fuel cell systems provide on-site power for entire data centers within 90 days of deployment, offering a rapid and reliable solution for Oracle's AI workloads and data center operations. This technology operates without air pollution and requires no water use, aligning with Oracle's sustainability goals and contributing to its net zero ambitions. Mahesh Thiagarajan, Executive Vice President of Oracle Cloud Infrastructure, emphasized the importance of reliable power for AI workloads, stating that customers expect to run their AI workloads and new AI applications at peak performance. Bloom Energy's fuel cell technology will support Oracle's growth strategy for large-scale AI workloads, providing ultra-reliable, clean, and cost-efficient power. This partnership is a significant win for Bloom Energy, adding Oracle to its portfolio of data center clients, which includes Equinix, American Electric Power, and Quanta Computing. Bloom Energy has deployed over 400 megawatts to power data centers globally and has installed 1.5 gigawatts of power capacity across more than 1,200 installations worldwide. This partnership is expected to drive revenue growth and margin expansion for Bloom Energy, solidifying its position in the rapidly expanding AI infrastructure market. For more on Bloom Energy and other companies, follow Ascencore. Thanks for watching and have a nice day.